Multiply that number from before, 44 and 444 thousandths times 10 to the second power. Explain the shift of the digits and the change in the value of each digit. So times 10 to the second power. So two different ways to answer this. The fastest thing to do is to move the decimal. We should know that the decimal never changes. It's always after the ones place, but I could go 1, 2. So I know that's going to be my answer. But it doesn't help to explain the shift in the digits and change in the value of each digit. Okay, so instead I probably should make a place value chart. Let's see, hundredths and thousandths. Then I think it's going to get big. So I'm going to need to make hundreds. And I'm going to need to make, let's see if that's better, thousands. So I'm going to put the number as we started off with here. Then what happens when it gets moved times 100 2 places over? 2 zeros and 100, 10 to the second power, it's going to get shifted 2 places over. 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. Divide the product from B. What's the product from B? That's the product of B. Divided by 10 to the third power. So instead we're going to move, the number's going to get a lot smaller. It's dividing by 1,000, 3 zeros and 10 to the third power. 1, 2, 3. That's our answer. Might want to show it. Oh, tenths. Oh, let's see, put a little decimal there. Getting a little messy here. Okay, all these numbers are going to move over how many places? They're going to move over 3 places. Let's see. Hundredths, thousandths, and then I got to go to 10 thousandths. Oh my goodness, that's a lot. That's a messy. Let's see. 1, 2, 3. 1, 2, 3. And right now I'm checking my answer. Because if it only got divided by 1, it would move over to the hundreds place. Or sorry, by 10. If it only got divided by 100, it would move to the tens place. But it must move to the ones place. Let's see. Now that one goes 3 places over to here. 1, 2, 3, and they all move over 3 places. Lava flow in Bikini Bottom was found to be 4.5 centimeters, or 4 5/10 of a centimeter, when rounded to the nearest tenth of a centimeter. Circle all the measurements below. That could be the actual measurement of the lava flow. So which of these will round to 4.5 centimeters? Nearest tenth of a centimeter. So let's look. If we find our place, look right next door, 5 or greater, add 1. Nope. This is never going to round to 4 5/10 of a centimeter. This one, if we're rounding to the nearest tenth of a centimeter, I look right next door. Let's see, 8 is definitely 5 or greater, so I add one more. 4 or less, number stays the same. Numbers behind 0 is your name. So did that round up to 4 1/2 centimeters? No. It just would round up to 4 4/10 of a centimeter. Let's see. Find our place. Look right next door. 5 or greater. Yeah. Add one more. 4 or less, number stays the same. Numbers behind 0 is your name. 4 6/10. That's not going to work either. Oh, that one looks real close to $4.50, $4.49. I know it's centimeters, but I just switched over. Let's see. I find my place. Look right next door. 5 or greater. Yep. Add one more. Numbers behind 0 is your name. Convert the rounded measurement, oh wow, to meters. Here's the rounded measurement. Now I need to convert it to meters. Write an equation to show your work. So if you're in my homeroom, I said none of these tests are easy. They require a lot of thought. Convert the rounded measurement to meters. Let's see. Well, 1 meter is really big compared to centimeters. So if I only have the tiniest little part of a meter, I'm going to definitely have less than 1 meter. So if I multiply and I get a big answer, that's telling me it's wrong. So instead, 4 5 centimeters divided by, there's 100 centimeters in a meter. 1, 2 is the same as 45 thousandths of a meter. Here's my equation. Write an equation to show my work. Well, this would be a good example of an equation. I could also write it this way. This part is the biggest, because if you don't, let's see, we still got some light. If we multiply by 100, we would have gotten an answer that would tell us 4 1/2 meters, which shouldn't make any sense. So a centimeter is much smaller than a meter. So that's why we have to divide by 100, or 10 to the second power.